Hi folks, today we are looking at a VFD display with a slightly different function than what we usually explore here on the channel. It is still a VFD display, and like every VFD, it also depends on a driver integrated circuit, which we will examine as well. In this case, the display works as a VU meter, which means volume unit meter, used to indicate the audio level of two separate channels. Each audio channel uses its own driver integrated circuit. The reference of this driver is a BA663. Unfortunately, it was not possible to locate a datasheet for this driver. However, we were able to identify the original device where this panel was used, and that information helps us a lot. This VFD panel comes from a Technics amplifier, model SUV4A-E. The service manual for this amplifier is available online, and that manual becomes extremely useful when we want to bring this panel back to life. Looking at the schematic, we can identify 7 connection points between the panel and the amplifier. The next step is to identify each wire, and for that we use a multimeter. Very quickly, we can locate resistors R822 and R823, which are connected in series with the filament supply. We can also identify the power supply pins. Because this VU meter operates with two audio channels, left and right, we expect several connections. When we analyze the circuit carefully, we arrive at 6 main wires. These are 2 wires for power supply, 2 wires for the filament, and 2 wires carrying the audio signal, one for each channel. That accounts for 6 connections. There is still one remaining wire, and when we check the schematic, we can see what it does. This wire connects to a transistor switching circuit that allows the system to disable both audio channels. The operation of this panel is actually quite simple. Once we connect the wires we identified, we only need to prepare the audio inputs correctly. To do this, we isolate the DC component of the audio signal using 2 capacitors of 4.7 microfarads. It is also important to carefully identify the common audio output pins. This is necessary to avoid accidentally creating a short circuit through ground, since the ground connection is shared. Remember that in its original configuration, this panel was installed inside the amplifier itself, where all the wiring is fixed internally. Because of that, the risk of incorrect wiring does not exist in the original design. But when we reuse the panel in a new project, we must be careful with these connections. The panel also includes a small amplification stage for the audio signal. This stage uses 2 operational amplifiers, packaged in a DIP8 format and identified in the schematic as IC803. There is also a switch that allows us to change the sensitivity of the meter. This switch selects between ×1 sensitivity and ×0.01 sensitivity. The adjustment works by switching between resistors R803 and R804. Using this approach, it becomes quite easy to reuse a panel like this, or other panels with similar characteristics. These displays can be integrated into simple audio projects, where they serve as a visual VU meter, and besides being functional, they can also greatly improve the final appearance of the project.
side, and after I go to the point to connect the filament wire and proceed with the wrapping. The second wire to the filament. In this case, I use the method of wrapping to connect the wires. But of course, you can connect the wire direct to the PCB, remove the pin, and after connect the wire direct. Okay, this is one option from from your side. The wire to the power.